Hello and Assalamu alaikum guys. Today we are going to start with this topic isomers. One minute. Isomers. What does iso means? Iso means same and mer means molecular formula. Now what is actually the definition of isomers? Isomers are actually those organic compounds which have the same molecular formula but different structural formula. Now here the question is that draw two isomers of butane. Now what we will actually do that first we're gonna read this note which says that putting the carbon on the edges doesn't make an isomer. Now come back. Butane C4H10, we know that its molecular formula is C4H10 and its structural formula is this one, the simplest structural formula, and so this is the first isomer of butane. So C1 2 3 4 C4H10, so this is the first isomer. Now how we gonna make the second isomer is that we gonna take this carbon or this carbon and attach it to such a carbon which is not at the edge. Like here we read in the note that putting the carbon like this carbon or this one carbon which is already at the edge, putting the last carbons, the last or the first carbon, by taking the last or the first carbon and putting that carbon on the edges. If we again put that carbon on the edge, it will not make an isomer. Like if we take this carbon and we put it on this carbon, so then this carbon will be on the edge, so it won't make an isomer. Or if we take this carbon and put it on this carbon, it won't make an isomer. Or we take this carbon and put it on this, no isomer. Or take this carbon and put it on this, it won't make an isomer. So how an isomer would be made? That if we take the first or the last carbon and put it on such a carbon which is not the last carbon, which is not at the edge. So now here if we took this carbon and put it on this carbon, like if there was a carbon over here, we took this carbon and put it on the second carbon, not at which is not at the edge, so it made a second isomer. Now pentane. Now pentane, so it is C5H12, its first isomer, simple. Second isomer, we take any carbon at the corner like this first or this last carbon and attach it to such a carbon which is not at the edge. So we attach it here at the second carbon. If we take this carbon and attach it on the second carbon, so it makes second isomer. And now how we will make third isomer is that we will we will make third isomer of this isomer. So now how we gonna make it? We will take another carbon on the corner or at the edge like this one or this one and attach it to such carbon which is not at the edge. Like if we take this if we take this carbon, we cannot take this carbon over here to make third isomer, because if we take this carbon then this carbon will be at the edge. So carbon attached to the carbon at edge, it won't make an isomer. So we're gonna take this carbon and attach it to this carbon. So we attach it to this carbon and this makes the third isomer. Now what's the name of this isomer? It is actually, look, 1, this is 1, this is 2, this is 3, and if we count from here, this is 1, this is 2, this is 3. So the two carbons which are attached to the same carbon, they both come on the same point, which is 2 from both the sides. From here 1, 2 and 3. So on the same carbon. So we can name it from any side. If we take this side, we will say that it makes 2 dimethyl di, for we're gonna name it 2 dimethyl 1 2 3, 3 carbons in a row. So what? Propane. So what its name? 2 for this position of the carbon, which is 2 over here. Di for these 2. If there was one like this, it would be 1, if we count from here, 1 2 3 4, and if we count from here, 1 2 3 4. Now which is the closest one? From here it is the closest one, so we will take this number, which is 2. So this is 2 dash. Now here it was di, here we will mono di tri tetra. So here mono, or we'll neither name it. For mono, will not name it. We will simply say 2 methyl 1 2 3 4, 4 carbons in a row. So 4 carbons in a chain. So what does it makes? Butane. Okay, 2 for this methyl, for 1 methyl. You know that from that this carbon is missing 1 hydrogen. It has only 3 hydrogen. So if there is 1 hydrogen missing, we have done this in our previous videos, that we will name that its name ends with yl, yl in the end. So 2 methyl, this is methyl because 1 carbon, so meth 2 methyl butane. 1 2 3 4, 4 carbons in a chain, so 2 methyl butane. And here 1 2 2 over here 2, so 2 di 1 2 dimethyl 2 dimethyl propane. 1 2 3, 3 carbons in a chain, so we will name it propane. And for naming this isomer, we will name it simply 1 2 3. From here 1 2 3, so same 2 2, so 2 methyl, since there is only 1, so 2 methyl 1 2 3, 3 carbons in a row, so propane, 2 methyl propane. It's very simple. Now the question is that draw 3 isomers of hexane. Now what is hexane? It is C6H14. So its first isomer, simple. Second isomer, we'll take any carbon which is first or last and attach it to such a carbon which is not at the edge. This is very important thing. So if we take this carbon and attach it over here on the second carbon, so its name would be, if we count from here, 1 2 3 4 5, and 1 2 3 4 5. So here 2, from here 4, so we're gonna take 2 2, only 1, so 2 methyl, and 1 2 3 4 5, 5 carbons in a chain in a row, so 2 methyl pentane. Simple. For here third isomer, 1 2 3 4, 1 2 3 4, so 2 first, so 2 di 1 2 di methyl 1 2 3 4, 4 carbons in a chain, so butane, 2 dimethyl butane. Simple. Now 2 isomers of butane. Now in case of butane, there's a note that in case of alkenes, shifting the double bond also creates new isomers. What was there in case of alkenes? That shifting the carbon, this one carbon, shifting the position of this carbon, it makes an isomer. Now in case of butane, if we can even shift the carbon, but if we also shift this double bond, that if we take it from here to here or here, it will make an isomer. So now it says us to draw 2 isomers of butane. Now first isomer of butane is as simple as this, first carbon and here, so butane. Now this is the second isomer, that we take any carbon. In first, we are not gonna shift, we are not shifting here double bond in the second isomer, so we are shifting this the position of this carbon. Like we take this carbon and attach it over here and on this carbon, so it makes 1 2 3 1 2 3 2 methyl single, 2 methyl 1 2 3 pentene this time. Oh sorry, propene. This time propene. Here it was in pentane, butane, propane. but here it's propene because now there's a double bond. So now in third isomer, how are we gonna make third isomer? Now we are gonna shift the double bond, like if the double bond was here, and consider this one. We are making the third isomer of this first isomer by shifting the double bond, and we shift this double bond from here to here. So what does it makes? Now how to name this? We have shifted this. So now how we are gonna name this one is that like what is this? Simply it is butane. What is 1 2 3 4? It is actually butane. Now but to ene, butene, and then there's a dash, so but 2, why 2, 1 2 3 4, and from here 1 2 3 4. So from here 2 also with this, and from here it's also 2, because from here the double bond is on this carbon, and from here the double bond is on this carbon, so 2 from both sides. So we are going to name but 2 ene. If it was propene, it would be prop-2ene, pen-2ene, hex-2ene, and likewise. So now the question is 3 isomers of pentene. First isomer, simple. Second isomer, we are gonna what we are going to do, we are going to shift this double bond. So we are shifting this double bond onto this carbon atom. So what is it actually? It is pentene. So we will do some numbering over here between pent and between ene. Pent dash number dash ene. So what will be the number from here? 1 2, so it is on 2, and from here 1 2 3, it is on 3. So we are gonna take this 2, so it would be pent number 2, pent 2 ene. This is pent 2 ene. Now what's the next question? The next question says to draw 2 isomers of butanol. Now this is the alkanol family. Now coming to butanol, this is C4H9OH. We know that first isomer, simple, 4 carbons, and then there's OH, so C4H9OH. Now there's a note that in case of alkanols, shifting the OH group, this OH group also creates isomers. In alkanes, we only shift carbon, this carbon. In alkenes, we shift the carbon and the double bond, and in alkanols we shift this OH group and the carbons. So what will be second isomer? We are shifting this carbon, so we bring this carbon from here and attach it over here, so it makes this. Its name would be 1 2 3 2 methyl single, as there's single 2 methyl 1 2 3 3 carbons in a chain, so 2 methyl propanol this time, because there is a OH group, so 2 methyl propanol. Third isomer of this first isomer, it would be like we are gonna shift this OH group. Now we are bringing this OH group over here to this, and it would make 1 2 3 4, so the OH group. Now we would again add number over here between all and between butane, so the number would be from here, if we count 1 2 3, it's on 3, 1 2, it's on 2, so from here it's more near, so we are gonna butane 2 all, number it 2, so it's easy. Now the next question is 2 isomers of pentanol. Pentanol's molecular formula, the first isomer, simple. Second isomer, this is the second isomer. We shift this carbon and attach it to this carbon, and here's, so its name would be 1 2 2 methyl 1 2 3 4 4 carbons in a chain, so 2 methyl butanol. Here's your name. And third isomer, we are gonna shift this OH group. And now why can't we shift this OH group and bring it over here, attach it to this carbon atom? Because it would be the same in both cases. It would be simple pentanol, pent one pentan one ol, or pentanol. Better name it pentanol in if it's on the first carbon, because from here this is the first carbon and from here this is the first carbon. So if we attach it to this carbon or this carbon, that's the same thing. No two different isomers. If you so no two different isomers. It would be the same pentanol from this side and pentanol from this side. Third isomer, so we are attaching it to this carbon atom, and its number would be 1 2, so pentan 2 ol. Simple. Now two isomers of butanic, it is actually butanoic acid. Now this time COOH. This is actually COOH. Okay, C3H7COOH, the molecular formula of butanol. Now note, in case of alkanic acids, now it's alkanic acids, the fourth organic family. Shifting this COOH group, this COOH group, functional group, which is functional group, also creates isomers. It also creates isomers. As there was OH group in alkanic acids and the carbon atom, now in this case, in alkanic acids case, the shifting the carbon atom and the COOH group, this whole group, COOH group, shifting this whole group also makes an isomer. So first isomer of butanoic acid, you know, this is the first isomer, simple structural formula of butanoic acid. Now second isomer, this C3H7COOH. Now second isomer, that 1 2 3, and we are gonna bring this carbon atom and attach it to this carbon atom, so it makes 1 to 2 methyl, 1 2 3 3 carbon atoms in a chain, so 2 methyl propanoic acid this time. What? 2 methyl propanoic acid, this is the long name. And so then third isomer, we are gonna shift this COOH whole group and bring it over here to to this carbon atom. As it is attached to this carbon atom right now, so we're gonna take it over here and bring it over here and attach it to this carbon atom, so it would make this structure, and its name would be, now we are gonna name between propan and oic. So the number would be 1 2 3 2 from here, 1 2 3 2 from here. So propan 2 oic acid. What? Propan 2 oic acid, this is its name. This was the end of the video. If you enjoyed it, if you learned from it, please give it a thumbs up, and do not forget to subscribe, like, and share. And in our next video, we are gonna start over with chemical reactions of organic families. So thank you.